Hello everyone, Mr. Taylor here. Well, we've been exploring dilations, the really last part of transformation, and we want to take this now and see how do dilation and measurements interact. How can we use one with the other? So, saying that, you will describe the effects of a dilation on a linear and area measurements. Okay, we're just talking about length times width or perimeter of some particular figure. So the explore activity for this lesson starts us off with says, okay, um, we have two rectangles. We have rectangle green, we can say, and then we have rectangle blue, we can say. If we look at it carefully, we know that rectangle green is the preimage or the original, and rectangle blue is the actual um, image. Okay. We also see that it is about A, and it's gonna be an enlargement. So if you could, let's go back with our rulers and record the measurements for in green. Do green first, AB, then do BC, and then do CD, and then DA. And then once you do that, come back and do blue A prime, B prime, do B prime, C prime, and then do uh, D prime, A prime. Okay, now once you completed that, then you want to take your ratios. You want to take your, let's make sure we do this one more time. You want to make sure that we take your new over your pre-image or your original. Okay, that's what you want to do as far as your ratio. And complete your ratios. All right. And then you want to take a look and sort of answer these questions. What is true about the ratio that you calculated? What scale factor was used to dilate the green rectangle to a blue? So we go back and look at it, we see that green is smaller, so remember it has to be something greater than 1. And how are the side lengths of the blue rectangle related to the side lengths of the green? Then look at the perimeter. The perimeter is if you can recall, the perimeter would be 2 times L. So we'll just put P is equal to 2 times L plus 2 times W. And for the actual perimeter, and that's for both green and blue. And what is the area? So we know from our 6th and 7th grade math that area equals to length times width. And then you want to know is how's the area of the blue rectangle related to the area of the green rectangle. And then once you finish with C, take a look at the number 1 reflection where it says look at this information. The perimeter and the area of 2 shapes below after dilation are given, and how are the perimeter and area of a dilated figure related to the perimeter area of the original figure? So you want to answer these questions too. So just please, if you don't mind, go back and start from here, stop it, filling out the information. Then go to this particular slide, stop it, fill out the information. Then this particular side, I did put the formulas up there for you. Stop it, fill out this information. Okay? All right, now that you're back, what do we have? Well, according to the author, I didn't measure it. I'm trusting our famous author. Uh, the measurements, and we're looking at them in centimeters. Uh, AB is 2. This is the smaller one. BC is 1.5. CD is 2. These are parallel, so they should be the same measure. And DA is 1.5. These two are parallel, and it should be the same measure. And the good part about taking these measures, because we could have looked at this from face value and say, oh, that's a square. But taking the measure will show us that it's not a square, because if it would, all sides would have been the same. So then look at AB, A prime, B prime. We have a measure of 4. B prime, C prime, we have a measure of 3. C prime, D prime, we have a measure of 4. And D prime, A prime, we have a measure of 3. Let's take our ratio. So we will have, for the first one, this one, we have A over B, A prime, B prime over AB. So here we have new over the original. We get 2. We do this one. Again, the new figure is 3. So we're going to take 3 and divide it by 1.5. We'll get 2. C prime D prime is 4. We're going to take 4 and divide it by our original. We'll get 2. And again, D prime A prime divided by our original, and we'll get 2. Okay? So, question. What is true about the ratio that you calculated? 2 equals 2 equals 2 equals 2. They're all equal. So what is the scale factor? Your scale factor, as we said previously, is the ratio. It's reduced ratio. So the actual scale factor is 2. And the green one was dilated by a scale factor of 2 to create the blue. And how are the side lengths of the blue rectangle? This one, the new, related to the side lengths of green, which is the original, they're twice as long. So it asks us, well, what is the perimeter? So the author got 7. Well, how did he get 7? And he's talking about for the green one. Well, 2 plus 2 is 4 plus 3 is 7. Or we could have said, like we said in the formula here, to get green, you could have said just 2 times 2 plus 2 times 1.5. And that's going to give us 7. Or should I say 4 plus 3, which equals to 7. And the next one says, well, what is the perimeter of the blue one? So then we're looking at 2 times 4 plus 2 times 6. So for blue, we have 2 times 4 plus 2 times 6, which will give us 8 plus, went way too fast on that one. I got a habit of putting my answer before before I go any further. That's 2 times 3. And of course, 2 times 3 is 6. So 8 plus 6 is 14. Then, how is the perimeter of the blue rectangle related to the perimeter of the green? The perimeter of the blue rectangle is twice that of the green. And we know that from our scale factor right here too. Okay, now let's talk about area. So it says, well, what's the area of the green one? So if we go back, we see that we have side length of 2 and 1.5. So we would have, for area here, we would have area is equal to 2 times 1.5, which would give us 3. And then it says, well, what's the area of the blue one? So here we have 4 and 3. So we go back and we would have area is equal to 4 times 3, which is, of course, 12. And notice that the author did put centimeters square here because your units, you are multiplying units times units, so you would get square units. Okay, so how's the area of the blue rectangle related to the area of the green? The area of the blue rectangle is 4 times. Wait a minute. Wait. 4 times. We said over here that we had a scale factor of 2. So how would the area be 4 times if we just have a scale factor of 2 and the perimeter is twice? Well, how would the area be? Well, because perimeter with area, since linear is 1, so you're doing 2 times 1, which is 2. With area, you're doing 2 to the second power, which is, of course, 4. And this is very important right here. We could have also did for perimeter, we could have said 2 to the first power. So please make sure that you understand this concept here, this concept as far as the area and the perimeter. Last, make a conjecture about the perimeter and the area of these two shapes, the information on these two shapes before and after dilation, and how is the perimeter and area of the dilated figure related to the perimeter area of the original. So original is 8, dilated is 16, so we know that that's 2 times, which would give us 2 times 8, which is 4, and dilated, we have 16 and 16, so again, we're looking at a scale factor of 2, and then here we have original is 30, so we're going to divide, it'd be dilated is 5, so that'll be 5 over 30, which will give us 1/6. Area will be 54 compared to 1.5. So the only thing that you just need to see there is the perimeter of the dilated figure is the perimeter of the original figure multiplied by the scale factor. And the area of the dilated figure is the area of the original figure multiplied by the square of the scale factor. So these are very two important concepts that you definitely want to put in your notes and be able to understand. All right. Thank you for watching.